The anomaly began as something so small that most systems would have ignored it. The Canberra Deep Space Station was performing a routine calibration sweep when a faint deviation appeared on the screen. At first glance, it looked like one of the thousands of meaningless fluctuations that radio antennas record in a typical night. A tiny shift in the object's predicted position, barely measurable, barely real. The standard protocol is to flag the data as noise and allow the automated filter to remove it. But for reasons still unclear, the technician on duty requested a verification pass. When Madrid's antenna followed up, the same deviation appeared again. Not close, not similar, identical. The timestamp matched down to the microsecond. Two separate stations on different continents, under different atmospheric conditions, had observed the same shift. That alone raised concern. Double confirmations like this usually mean the phenomenon is real. When Goldston ran a comparison against the predicted orbital path, the data became impossible to ignore. The object was no longer following the expected line produced by gravity alone. Instead of maintaining a stable outbound drift consistent with an interstellar object under weak solar influence, it displayed a slight inward curvature. Something was guiding it, something subtle but persistent. Engineers attempted to remove sources of error. They recalculated solar radiation pressure. They factored out gravitational resonance. They removed the contribution of passing particles and even ran the simulation without perturbations entirely. Yet the object's path continued to bend in the same direction. This was not a calibration issue, not a thermal fluctuation, not a background artifact. By the end of the night, NASA classified the deviation as an anomaly of interest. The object had moved in a way no known natural force could fully explain, and this was only the first sign that something unusual was approaching. Acceleration in space is simple. If a natural object speeds up, it must be pushed by something, a jet of gas, a collision, or a gravitational assist. But when NASA's Jet Propulsion Laboratory examined updated tracking data, the object's velocity curve did not match any natural cause. The acceleration was clean. It rose smoothly, without fluctuation, as though guided by a constant invisible force. Comets accelerate when volatile gases erupt from beneath their surfaces, producing measurable outgassing signatures. These events create heat spikes, rotational changes, and a plume visible in infrared. But none of that appeared here. The infrared map showed no hotspots. The rotational rate stayed unchanged. Spectral imaging revealed no trace of escaping material. In other words, the object was accelerating without a physical engine. Scientists considered the possibility of measurement error. Space is full of deceptive signals. Cosmic rays strike detectors. Charged particles distort readings. But when Japan's Subaru telescope confirmed the same velocity increase independently, the error hypothesis collapsed. The acceleration also had another unusual trait. It was too consistent. Natural changes happen in bursts, small pushes, irregular impulses. This movement looked like a continuous application of force, similar to ion propulsion or magnetic steering. But an object of this size should not have access to either. One theoretical model suggested that the object might be shedding extremely small amounts of mass in a way too faint for detection. But the consistency of the movement contradicted this. Nothing in nature acts with machine-like steadiness. By this point, NASA still avoided using the word controlled. But privately, researchers noted that the object was behaving as though it were adjusting its speed deliberately, and whatever force was responsible left no trace behind. A next mystery came from the solar-wind interaction model. Normally every object in space, no matter how large, is brushed by streams of charged particles emitted by the sun. This interaction exerts a faint but measurable force known as radiation pressure. Predicting it is straightforward. The solar wind slows some objects and pushes others depending on their angle and composition. But this object behaved as if the solar wind wasn't touching it at all. When NASA's Solar Physics Division compared the expected pressure to the observed motion, the difference was striking. According to physics, the object should have experienced a slight outward push. Instead, it moved through the solar wind undisturbed. The particles appeared to scatter around it in a pattern inconsistent with natural materials. Spectrographic analysis offered no simple answers. The surface did not reflect or refract particles in the way dust or ice normally would. Even metallic asteroids show clear signs of solar wind interaction. This object absorbed or redirected the particles in a way that left almost no signature. Some researchers propose that the object was coated in an unusually dense layer of dust from interstellar space. Such a layer could dampen solar wind effects, but the dust halo hypothesis required thickness levels far beyond anything observed in the past. And even then, the motion should have shown small irregularities as particles accumulated or drifted away. Instead, the trajectory remained exceptionally stable. The most curious part came from magnetometer readings. The object showed no magnetic field of its own. None. Even comets and rocky bodies carry small magnetic residues. Yet this one was magnetically silent. The solar wind did not bend toward it, or away from it. It moved as though unaffected by the sun itself, and no natural object should be able to do that. It took several days before astronomers noticed something subtle happening to the object's rotation. At first, it seemed to tumble slowly, which is normal for small interstellar bodies. Tumbling is a natural outcome of collisions, uneven heating, and past gravitational interactions. But the motion gradually changed. Instead of spinning erratically, the object began to settle into a controlled rotation. The rotation axis aligned itself toward a fixed direction in space. Objects do not do this unless they are being influenced by external forces or using internal mechanisms. NASA compared the orientation to gravitational vectors. Nothing nearby could have caused the alignment. There were no large planets close enough, no passing stars, and no magnetic field strong enough to direct the object's spin. The steady rotation began to resemble something else: stabilization. Satellite engineers recognized the pattern immediately. It looked similar to the way spacecraft use small internal systems to align themselves before conducting maneuvers. But no one wanted to say the word. The scientific community prefers caution over assumptions. The strangest part was the rate of adjustment. It was gentle, almost smooth, with each shift occurring over hours. Natural bodies adjust their spin through impacts or sudden forces. This one transitioned gradually, as though it were responding to a faint internal process. Even more unusual was the precision of the final alignment. When mapped backward, the orientation pointed toward the same region from which the object originally entered the solar system. This suggested some form of memory or structural consistency. Nothing in the data looked unstable. Nothing suggested disintegration or stress. The object rotated with purpose, and as it continued its approach, the rotation held steady, adding a new layer to the mystery. NASA's infrared array was the next instrument to examine the visitor. Infrared imaging is one of the best tools available for reading surface composition. Natural bodies heat unevenly. Some regions warm as they face the sun, others cool as they turn away. This creates a thermal map, but the object had no thermal map. Its temperature was uniform everywhere. This alone was deeply unusual. Even metallic objects heat unevenly in space because sunlight does not fall equally across their surfaces. Yet the entire body remained at nearly the same temperature, varying by only a fraction of a degree. The uniformity suggested one of two things. Either the surface was composed of a material with extraordinary thermal conductivity, or the object contained an internal mechanism distributing heat evenly. Both possibilities were rare. Neither matched typical interstellar debris. Researchers then looked for hotspots indicating outgassing or internal activity. None existed. The surface did not flicker or fluctuate. No streaks of evaporating material were detected. Even the cold side of the object had the same temperature as the sunlit side. That should be impossible without energy redistribution. The thermal silence raised another question. If the object was not absorbing heat normally, what was it doing with the energy it received? The data hinted that much of the incoming radiation disappeared without reflection or emission. A surface that absorbs radiation perfectly, without heating significantly, is extremely rare, bordering on engineered. One physicist described it as looking at an object that refused to reveal its internal structure. The infrared scanner saw only a smooth, consistent temperature. No texture, no variations, no clues. The more NASA observed, the more it became clear that this visitor was not behaving like any natural body we have catalogued before. The next discovery came not from direct imaging, but from gravitational readings. The Deep Space Network tracks small fluctuations in space-time caused by passing objects. Even small bodies produce faint distortions as they move. These distortions reveal mass, density, and structural composition. But when the object passed near a reference beam used to measure deep space timing signals, something unexpected appeared. A faint gravitational ripple followed the object, as though its movement left a temporary imprint behind. The phenomenon was subtle, too subtle to suggest another object or a fragment trailing behind it. Instead, it looked like a temporary displacement of space, similar to the wake behind a ship moving through water. Except space does not behave like water. Nothing should leave a wake. The ripple lasted only a few minutes before fading. Instruments in Chile observed a similar signature hours later. The readings were too consistent to be noise, and the shape of the disturbance indicated something unusual about the object's mass distribution. The density was inconsistent with anything naturally produced. The internal mass seemed uneven, with regions of higher density arranged in a pattern. This configuration did not resemble rock or ice, it resembled structure. A hollow interior was considered, but the pattern did not match a simple cavity. Instead, the gravitational echo suggested internal partitions, layers, possibly chambers. Researchers remained cautious. Gravitational interpretation at long distance is always uncertain, but the ripple implied more than a solid object drifting through the solar system. It implied internal design. If the mass distribution was artificial, even partially, then the object carried more complexity than an ordinary interstellar rock. And if the gravitational echo was real, it indicated something no natural body should be able to do. It changed the space behind it. The moment NASA could no longer treat the situation as a passive event came when the object altered its trajectory. The adjustment was small but unmistakable. Natural bodies change paths only when something pushes them. But this object had no nearby planets exerting influence, no jets of material emerging from its surface, no energy output, yet its orbit shifted. The first correction adjusted its path by a fraction of a degree. The second came hours later, then another. Each one was measured. Each one was precise. Researchers tested every explanation. Could it have been solar wind? No. That would have pushed the object outward. Could it have been thermal outgassing? No signs of gas surrounded it. Could it have been a gravitational interaction? Nothing large enough was nearby. The adjustments looked like micro-maneuvers, small, controlled changes in direction. If the object were tumbling naturally, the corrections would have created visible rotation changes. But the rotation remained steady. That meant the adjustments were internal. Some engineers proposed that the object contained mass-shifting mechanisms similar to reaction wheels on spacecraft. These mechanisms move internal weight to rotate or change direction without external fuel, yet such systems require precision engineering. The path correction directed the object toward a new arc, one that led it closer to the plane of planetary orbits, not dangerously close, not in a collision course, but close enough to be monitored actively. NASA sent internal updates describing the movement as behavior inconsistent with natural celestial mechanics. That was the closest thing to an admission. Whatever this object was, it had responded to something. It did not drift into its new path. It chose it,